Hello, let's do the New York Times Hard Sudoku for April 15th, 2025. There's a link in the description if you'd like to try the puzzle yourself, and I'm going to get started right now. We're going to start with our standard geometry pass. I'm going to try to explain this as best I can of what I'm actually looking at here, because I keep getting questions. What do you mean by geometry? The reason it's called geometry is you're looking at the locations of the digits rather than the values. And I'm going to take the time here to show you what I mean. And I'm going to black out. Now, just pretend you can't read it. Unfortunately, you can still read the digits. I wish I could make it so you couldn't read the digits to really drive this home. We do not care right now what the digits are. This is a scanning technique to speed up finding interesting things in the puzzle. And we're looking at the geometry. We're looking at where are the black squares and where aren't the black squares. So this 1, 6, right? They aren't in these two columns and they aren't in this row. And what I'm looking for is if any of those columns or that row have a lot of black squares in them. That's all I'm looking for right now. Like we're not worried about what the digits are yet. We're going to have to if we find something interesting, but we're not worried yet. And so I have two black squares here, and they are not touching this column and this column, and they're not touching this row. This row only has one black square. We can ignore it. This column has two black squares. That's not really enough. Remember that we can have up to 9 black squares in a row or column. What I'm looking for is, I'm specifically, by the way, looking at the row and the column not in the box. We don't care about the box itself that we're looking in. So we're focused on box 1 right now. We don't care about the cells in the box itself. So there's 6 cells here, there's 6 cells here, and there's 6 cells here. We're going to look at them one at a time and go, how many of those 6 are occupied? The best case scenario is if 4 of them are occupied. If there's more than 4, we probably don't have a geometry thing going on, but you can look anyway. 3 is probably fine too. Like we might be able to find something with 3. With 2, we're not going to bother right now. We'll find that with a later, more intensive scan. So this only has 1. This only has 2. This has 3. It could be worth looking at this. And so now what we have to do is we have to follow up. Let's just reveal these digits here. We have to follow up. The first thing we need to follow up on is, now that we've identified an interesting set of digits here and an interesting column to compare it against, we need to see if there's any repeats. So this is 1 and 6. This is 2, 3, and 7. There are no repeats. So now we move on to the next step. Look at the empty cells in the column. And in those empty cells, again, we can just cover this up again, because now we know we need these digits, but now we know that these aren't the same, so we don't have to worry about them. We're looking at these empty cells. And we're saying how many of these cells can take both a 1 and a 6, or sorry, can take either a 1 or a 6. This can take either a 1 or a 6 and take both. This can take both. This can take a 6, but not a 1. We do have to look at these values at that point. We see this 1 here. So unfortunately, we have not found something. We need to make those numbers match exactly. We need 2 open cells. That's why having 4 of the givens here would have been better. So now we can just cover this back up. Now we're looking at these 2. What aren't they in? They're not in this row. They're not in this column. Neither of those are interesting. Here and here, I only have 1 black square compared to my 2 here. I want like 3 or 4. Now this box is usually the most interesting formation, or variance of it, where I have 3 black squares in this box, and they're all avoiding this row. So I just need to compare against these 6 here. And so I see that I have 2 here versus 3. 3 would have been better. 2 is okay, but first thing we need to do is we need to reveal these digits and go, are there any repeats? There are not any repeats. 5 and 6 do not match 3, 4, and 9. So we're good to go. We can now compare against these 4 cells. And what we're looking for is if there's any cell here that also can't be 3, 4, and 9, because we need 1 more cell to remove. This can't be 4 or 9. That's pretty interesting. This can't be 3, but unfortunately, this could be a 3. So we have to count this cell as possible. This can't be 3. These are both 5. So unfortunately, we don't see it, but that's the closest we've gotten so far. And again, I'm sitting here and I'm taking my time explaining exactly what I'm looking at. You can get done with this geometry pass in 30 seconds, and you can immediately find if there are any some really interesting things to find about the puzzle right away. If I don't find it in this puzzle, look at yesterday's video. I found something interesting in yesterday's video. All right, so now the other thing we could look at is we have these black squares, these black squares. It's really only worth looking at if you're seeing some very heavily occupied rows or columns here. You kind of have to kind of make a value judgment on whether that's worth looking. I don't think that's worth looking at. This box has a lot of black squares in it. So for example, I've got 4 black squares here, and I've got 4 open cells here. So this deserves a follow-up. We reveal these and reveal these, and then we get a little disappointed because 2 and 7 repeat. So really we just have these 2 that need to go in these 4 places, the 3 and the 9. So unfortunately we can't do anything with that. We'll cover these back up. But we also have these 4 against this column, and we can look and see that this column has only 4 open cells. So we have these 4 black cells here against this column, which has 2 black cells. And so remember, 6 is our magic number. And so 4 plus 2 is 6. And so we might be good to go, but we still have to, again, we have to compare. Do 1 and 6 repeat here? No, they do not. So what we have found here is a hidden quad. So what we can do is we can say, well, we need the 2, 4, 7, and 9 to be placed in these 4 cells. Therefore, they are 2, 4, 7, 9 in some order. This one's not a 9, so I can actually corner mark the 9 down here. And we can follow up on that by saying the 9's in one of these 2 then. In addition to that, that means that we can always do the corollary, especially when we find it matches exactly 1 to 1. This 1 and 6 need to end up in this box here. So we can see the 6 looks down, this 6 looks in. I'm kind of peeking that that's a 6. This 6 looks down, that 6 looks in. So we can place the 6 here. And then now the 1 needs to be placed somewhere it's placed there. And then this ends up being a pair. So this is, we have 1, 2, 3, we need 5 and 8. And so we get this immediately. We get this 2, 4, 7, 9 hidden quad, the 5, 8 pair, and the 6 and 1 get placed immediately. Now, I'm not going to keep these 2 marked because I don't mark cells with only 4, and this 5, 8 pair should do enough to remind us. Now, I'm still doing my geometry pass, so I'm just going to black out any digits that we have still, and we're just going to continue. We still could look against, say, this row again. We have the 1, 2, 3, 7, 9. We know the 2 and 7 aren't there, so we need 1, 3, and 9 here. And we're not lucky in finding like 1, 3, 9 restricted, so we can't do anything with that yet. I think that's what we're going to find here. I mean, we have the 1, 4, 6, 7 that need to go here. And actually, I am noticing we have this 7 and this 7 here. And we have this 7 here. All right, this is filled. That's even better, right? We still need a 7 in the row. That's the important bit. So none of these can be 7s. We can actually place a hidden 7 in the row. Okay. And again, we'll do our normal scanning later, but we're going to keep doing geometry scans. So now this is 6, 7, 8. We actually just placed that 7. We want to compare against here and against here. We actually can't place the 8. Oh, we can place the 8 actually. So this 8 here needs to go somewhere in this row, and we can see we have this 8 here. So this type of geometry scanning gives you exactly what to like laser focus on to really quickly get digits. Notice how quickly I'm getting these digits. That's 8, that's 5. And I'm sitting here explaining it. And I guess we are 8 minutes in. 8 minutes is sometimes the entire solve time of a puzzle. But I'm taking my time and explaining exactly what I'm looking at because I keep getting questions. What do you mean by geometry? I still don't understand. I've watched it a million times. So hopefully this will really, really give you the true sort of geometry concept drilled in. And I think blacking out these cells is helpful for that, to sort of help you go blur your eyes and focus only on what cells are black, right? What cells aren't black. All right, so that covers this sort of grouping of cells. We have this grouping of cells, the 2 and the 7. Look, we actually found it again. So this 2, 7, we have these 3 black. Oh no, we didn't. Unfortunately, we didn't find it. Ah, darn. For some reason, I thought there were only 3 open cells here, but no. So 2 plus 3 is 5. That does not reach our magic number of 6. So we'd have to look a bit more carefully, but we can still take a quick gander, see that 2 and 7 do not match 4, 8, 9. So we're on the right track. But these 3 cells, none of them have restrict both 2 and 7. So unfortunately, we can't restrict the 2 and 7 in this way. So we'll just black these back out. You could look at the 2, 7 against this row and this row, but I don't really think we're going to find anything with that. We have 2, 7 here already. We have 7 here already. All right. This 3, if there's only 1 in the box, don't even bother. We'll find that with a normal scan. We're looking at groupings of digits. This 1 and 5, it would only be good against this row or this column, but it just isn't. And then this is an awkward one because we kind of have to group these together and these together. Just in your mind, just like use your kind of grouping mechanism in your brain, right? And kind of see that this would group this group. You can also look at like the 1, 5, 8 here or the 4, 5, 8 here. That could be useful. So for example, 4, 5, 8 here, these black squares, these 3 black squares against this column. Again, we only care about these 6. So if we add these up, we do have 5 black squares. And we can see that the 2 and 3 don't match. So this would be a candidate to look at something. And so we're looking at how 4, 5, and 8 might appear in these 4 cells. I'm seeing that neither of these are 4. So we know that the 4 ends up in one of these 2. That's already kind of useful. We unfortunately can put the 5 in 2 places, and then the 8 can't go here, but it can go in these places. So that's all we get out of that. All right. We could look at the 1, 5, 8 against here, but there's just not there's only 1 black square here. So yeah, that's all I'm seeing that looks interesting. And we finished all our boxes. Now we can just reveal all our digits and see, look, we got a whole box filled. So we did very well in this middle band. And because we did so well in this middle band, I'm going to start there. So I already know I'm going to find a buddy in this box here. It's filled. So, but we already have both of our 7s. So I'm just caring about the 2, 6, and 8. But I do want to check the 7s vertically. Okay, we have these 7s. It puts a 7 in one of these 2. When we corner mark 7s like this, not just 7s, but in this case, we corner mark 7s like this, why didn't I corner mark a 7 in this cell? It's really not a trick question. It's a very easy question. I didn't mark it there because there's a 1 sitting in there. But that's the only reason. There's not a 7 yet in this row. So what we have learned here is that there is no 7 here. And we've learned it in a non-trivial way. We've learned it because not because of a given, but because of these claiming 7s. And so what we want to do is we want to look to see where 7 can go in this row. It's not where the 3, 8 is. It's not where this 7 is. But unfortunately, that's all we get. So it's not limited to enough cells to do anything with. A few enough cells. Anyway, this 7 vertically, I don't think is helpful at all. Okay, so the 2 is going to have a buddy. So let's mark that. Again, check for 2 in this column. It's going to be in one of these cells, but one of those 4. All right. And then the 6 and the 8 over here. So we have this 6, 8 looking in. So the 6s are down here, and the 8's in one of these 2. We have this 8 helping. All right. So let's look vertically. The 6, 8, and the 2. Nothing vertically. All right. We have some low-hanging fruit. This row is down to 4 digits. We need 1, 3, 5, 9. This can't be 1 or 5, so this is 3, 9. This can't be 9, so this is 1, 3, 5. This can't be 5, so this is 1, 3, 9. All right. I'm a little bit curious about this cell just because it's not a bunch of these corner marks. So it can't be 1, 2, could be 3. It's not 4, 5, 6, 7, or 8, or 9. Oh, this is a naked 3. There you go. I told you it was suspicious. So let's just check again. It can't be 1, 2, 4, 5, 6, 7, 8, 9. So I knew this cell would be restricted. I did not know it was going to be a naked single. I knew it would be restricted because it's not the 2, 7, and it's not this 4, 6, or 8. But I thought it would be down to like maybe 3 digits, not a naked single. But there we go. So now that this isn't 3, we know the 3 is over here somewhere. Or we could just use the buddy. It also has a buddy vertically, and this 3 looks in, so that places this 3. That has a buddy there, puts a 3 somewhere down here. All right. I hope this in-depth one is helpful for some of you. Certainly taking longer than it should, but that's okay. It's a walkthrough, not a speed race. Some may accuse me still of going too fast, though. Let's see. This row has now been reduced to 4 digits, so I want to look at that, and same with this row. So basically, I'm going to be looking at every cell, but we're going to do it based on the rows. So this row needs a 2, 4, 8, 9. So we know neither of these are 8. So these are 2, 4, 9. And neither of these are 2. So these are 4, 8, 9. That's not a 4. And then these 4 digits are a 1, 4, 5, 6. This is not a 6. So this is 1, 4, 5. This can't be 4 or 5. So this is only 1, 6. This can't be a 1. So it's 4, 5, 6. And this can't be a 4. So it's 1, 5, 6. All right. I'm suspicious of this. Oh, very suspicious of this. We actually have a 1, 5, 6 triple in this box. When you mark something is the best time to find the triple. So as soon as we marked the 3rd in the triple, that's when we should find it, ideally. So we marked this 1, 5, 6 triple. Now, I'm going to explain this too, because today's explainy day. Why is this a naked triple? I get this question sometimes. Because when people are looking for naked triples, they assume you have to find this 1, 5, 6, 1, 5, 6, 1, 5, 6, and they would accept that to be a triple. But some people have trouble then taking that step forward and understanding why it's a triple and why it's okay that this can't be a 6 and this can't be a 5 and we still have a triple. So let me explain this very clearly. This is the way you should be thinking about naked triples. This cell, and this cell all need a different digit from each other. The 3 green cells here all need a different digit because they're in the same box as each other. That's because of the box in this case. It could be because of a row, it could be because of a column, it could be because of a box, or some combination, like row and box or column and box. But they definitely need to be different from each other. That's the first thing to understand. So if there are 3 cells that all need to be different, how many different digits do I need? Again, I'm not asking any trick questions. I'm leading you on very, very clear path to get to this logic. So if I have three cells and I need to put a different digit in each cell, how many different digits do I need? Well, I need 3 different digits, 1 per cell. Okay, so how many digits do I have available? How many unique digits do I have available? So what I'm going to do is I'm going to use a scratch just in this. Let's just do it nearby. I'll use this cell here. I'm not actually penciling what this cell can be. I'm using it as a scratch space to show you what's going on in my head. So I'm just going to go through each of these green cells. And I'm going to just name every digit. I'm going to name the 1, and I'm going to name the 5. And don't worry about this being red. We're using this as scratch space. So I named the 1, I named the 5. Now I'm going to name the 1, but I say I already have the 1 accounted for. I'm going to name the 5. We already have the 5 accounted for. Now I'm going to name the 6. Okay, I can add that. Here I'm going to name the 1. It's already there. And the 6. It's already there. So now I've named every single digit that can go in the green cells somewhere because of how we penciled them, right? And there's only 3 of them, the 1, 5, and 6. So the only 3 digits I have available that could possibly go in these 3 cells are 1, 5, and 6. But I need 3 digits for 3 cells. So I have to use all of them. I have to use up all of them. Now, if this could be, for example, a 7, I mean, everything I type is going to be red. But if this, for example, could be a 7, now I've got 1, 5, 6, 7 available. That's 4 digits for 3 cells. I can't do anything with that. It's almost there, but it's not there. And almost in Sudoku can be used in really, really strange cases that I'm not going to go into. Very advanced techniques, like almost lock sets and things like that can form chains and stuff in certain situations, but we're not worried about that. If you see 4 digits are available for 3 cells, that just tells you keep an eye on it, but you can't do anything with it yet. But unfortunately, we are down to 3 and 3. So the 1, 5, and 6 are going to end up in some order here. Now remember that these 3 digits shared a box. They share this box 6 here. They're all in box 6. So if these are going to have the 1, 5, and 6 in them, the rest of box 6 cannot have a 1, 5, or 6, right? No matter what I do, if I fill 1, 6, 5, I can't have another 5 or 6 in the box. If I fill 5, 6, 1, I still can't have a 1, 5, or 6 in the box. If I fill 5, 1, 6, right? Those are basically our options. It's going to use up the 1, 5, and 6 in the box, right? We're literally saying these are going to use up the 1, 5, and 6. Therefore, the rest of the box cannot have a 1, 5, or 6. Therefore, this can't be 5 or 6, so its only option left is a 4. So it must be a 4. So that's not a 4. That's not a 4. This is now an 8-9 pair. For some reason, pairs are easier to understand by a lot of people, but it's the same exact concept. I have 2 cells here. One of them is going to have to be an 8, and one of them is going to have to be a 9. So I can't have any more 8s or 9s in the row or the box because they share both the box and the row. So these cannot be 9. And then this is still down to 1, 3, 5, 9. Okay. Cool. And I think that's what we get out of this. That's what we can do. We got the 4. 4s are done that way. 4s are kind of known this way. Okay. So I think that's what we get out of that band. And I think this probably would have been this would have been a pretty quick puzzle. So people looking at my time are going to get confused, but hopefully these explanations are helpful and I can point at this video, hopefully, if people need that. All right. So I'm going to finish this puzzle a little bit faster. I think I've covered most of the stuff we need to cover, but I'll still remind you of what I'm doing, of course. All right. So I finished this band. Let's move back up to this band, which I skipped because I knew this band would have a lot going on. Yeah, so we have the 1 and the 6, no matches, but vertically we have some matches. So these ones look down, this one looks in. We can place the 1 in this box. No follow-up on that, I don't think. There is one follow-up, which is I've created this is another sort of geometry thing you can look at. Sorry, I am explaining more. This geometry, you can kind of reverse it and look at these. Actually, specifically look at this row. I'll call this looking for crossings. I haven't done this very much because I kind of been doing it with a different method of scanning, but you could definitely look for this, and it's a nice way to just kind of spot check if there's something really nice to find. There is actually in this case. So these two black cells, right? We're back to looking at black cells. These two black cells are they share a column, and so there's going to be one row that they aren't in, right? Because they're column aligned, so there's going to be one row they aren't in. This row. We don't care about what's in the box. We care about looking for black cells that are in this row. Okay. And so this 1 and 5, we now have to compare the digits. Are there any unique ones? And yes, there is a 5. So the 5 looking through here, notice on its own, this 5 eliminates from 3 cells in this box. Now what we want to do is we want to look here and here to see if there's any more 5s. We do find one. And now we've hit jackpot. This 5 and this 5, notice how they both miss the 1, 3. They cross each other and don't hit the 1, 3. And so the 1, 3 are occupying 2 really important spots that 5 could have been in. And they're occupying it in a way that it leaves just these 2 left. Now, if I look right, I can actually see that I have this 5 also. So I have an even better situation. But at the worst case scenario, if you find this, the duplicated digit in that specific formation, you're going to get pointing 5s. So you can quarter mark them, and they would point up, and they would affect this column. But even better, this 5, it can't go here. So the 5 ends up here. But you still want to follow up on it. Match it with the 5 we already knew about. And put a 5 on one of these two. All right. So that was a follow-up that I did based on placing that 1. So there's all sorts of different follow-ups you can do after placing a digit. And the better you are at just glancing at the geometry of things to see what might be interesting, the more likely you are to find something interesting. All right. So that was the 1. We also have the 6. 6 goes in one of these two. What do we want to do to follow up on this? We want to look at this row. Where does 6 go? It goes in any of those 4, but if you don't look, you don't find the good stuff. And you don't find the good stuff unless you look. All right. That's 1 and 6. Here's 5 and 7. Again, no horizontal neighbors, but we do have 2 5s here. And so actually 5 ends up in one of these two. And then the 7 we already marked. I really want this 3, 4, 9 to do something. No, we haven't placed a 3 down here, unfortunately. Oh, we won't place a 3 down there. Okay. It has the 4 and 9. That's why I want to, but we won't. There's a 3 there. Okay. 5 and 7, the 3, 4, and 9. Vertically, 3s are done. 4s are done. 9, unfortunately, doesn't seem to do anything. All right. So this band didn't have much to find. We already did this band. Let's do the bottom band. So 1s are done horizontally, 5s are done horizontally. Once we're on the final band, we don't have to worry about verticals because we've hopefully already looked at verticals. Although I think I ignored the verticals here. So let's do them here. We have the 3s. 3s in one of these two. We have the 5s, which we got, and then the 1 we got. Okay. So we don't care about 1s and 5s, which really narrows it down. We have the 3s marked already, and the 4 and 8 don't have a buddy. All right. So that's it for our initial scan. So we did a geometry scan, we did an initial scan. I think you can get this done in 5 minutes or less. I believe in you. I think you can do that entire scan in 5 minutes or less if you practice at it. Now we haven't finished the puzzle, not by far, but the next thing we want to look for is what I call low-hanging fruit. It's just because it's the easiest place to look. You're in this situation, you're like, I've done my scans, I don't see any more geometry. What can I do next? Well, the thing to look at next is, are there any rows, any columns, or any boxes with only 4 or fewer open cells? If so, we want to at least peek at what those digits are that are still needed. Because if there's only 4 digits left in a row, column, or box, I kind of find that to be a critical mass where 1, it's pretty easy to keep 4 digits in your head at once. Once you get to 5, it's a little harder. And then also you can kind of easily scan to see, they're more likely to get restricted down to 3 or fewer, which we can mark. Very likely to. So I'm just going to, if you want, you can just systematically look at every row. We've already looked at these rows. They are down to 4, but we already looked at them. And see how many have 4 open cells. And this, again, is where you want to be scanning the givens, not the empty cells. Well, kind of. This column has 5 left. This column has 4 left. So this is our first low-hanging fruit. And I'm already seeing this is going to be really, really nice because I have the 5 and 9 corner marked up here. So if I have 4 digits left and this one isn't 5 or 9, it could be a naked single. So we definitely want to look at this column. We were going to anyway, though, but this is one to look out for. So we've got 4, 5, 8, and 9 left. So we know that this isn't the 5 or 9. So this is only 4, 8. So it's not a naked single, but it is a buy value, which is nice to mark. Now we know that this one's not 9 and this one's not 5. So we can already fill 4, 5, 8, 9 and clean up the 9 and the 5. This can't be a 4, so we can fill 5, 8, 9. So we got to fill the whole column with try values or buy values. Unfortunately, we didn't really learn anything new. We want to look at everything we marked and see if they caused a pair or a triple to form, but they did not. All right, this column here has 5 left. No, it doesn't. It has 4 left. Let's take a look. We need 2, 4, 7, 9. 2, 4, 7, 9. Unfortunately, we don't have more to do with that. This has 5 left. Okay, this box has 4 left. I think that's the last low-hanging fruit on the grid. All right. So what does this box need? It needs a 2, 6, 7, 9. These aren't 2, so the 2's in one of these two. So these are 6, 7, 9. This one's not 7, so it's 2, 6, 9. Okay, that's not exciting. But something I didn't notice, but marking these, I was kind of glancing at this column because I kind of had all these marked already. It's kind of instinct to just look up and see, well, there's 5 left, but I'm kind of looking and seeing, okay, there's a digit unaccounted for. And this is a good skill to have, is to be able to like look at these 3 cells and go, okay, how many unique digits are there among these 3 cells? And it's 6, 7, 8, 9. That's 4 unique digits, but we know we need 5 in the column. So what is the digit that isn't in any of these? Because it's going to be locked up here. The digit that's not in these is 5. And notice this can't be a 5 either. So we have found that this column needs a 5. This 5 says not here. This 5 says not here. And this 5 says not here. But that is not how I found it, right? I found it by looking at these markings, grouping in my head together to go, that's 4 unique digits. It's a really good thing to be able to do because if it's 3 unique digits, that's a triple, right? But it's 4 unique digits. But I know I need 5 in the column. What is that 4th digit? Sorry, what is that 5th digit? It's the 5. Where can the 5 go? Only here we can place it. And now that has removed those 5 corner marks. We can place this 5, which removes our 9 corner mark, which places the 9, leaving us with this 4, 8 pair for the column. We want to make sure we follow up. We have these 9s. It puts a 9 at one of these two. Where does 9 go in this column? It can go here or anywhere down here. All right, so not helpful. So far that hasn't been helpful, this puzzle, but when it is helpful, it's very helpful. Our 5's done. So what I noticed is I placed this 5 and we have them done in the band and the stack. So I like to just check how close are we to done entirely for the puzzle. And we'll see that 5 is limited to here. So it's not resolved yet, but it is limited to these 4 spots. Okay. So that leaves this to be 6, 7, 8, 9. That's what's left for the column. Can't be 6, 9. So it's only 7, 8. When we place the 7, 8, we of course want to be checking to see if we created any pairs, but unfortunately we did not. Okay, so that was great for that column. We placed this 5. Does that help us anywhere else? Place this 5 as well. So this is 2, 4, 7, 8. But we already know the 3 is here. So that is our 5th digit. So I don't know that I have any more like really good low-hanging fruit to look at. Let's see if there's... There's a couple things you can scan at this point. One is... just go box by box and look at your markings just to make sure you didn't like mess up like a scan, right? We want to make sure our 3s are respected, our 6s are respected, our 9s are respected. A lot of these actually come from the other way around where they're not pointing or claiming. They're just restricted because of the givens already. But I don't have, in my marking system, I don't have a way to distinguish those. So I just relook at all of them. Unfortunately, nothing for that. So now what I have to do is I just have to look at rows, columns, boxes with 5 or fewer. Which is unfortunate, but I'm going to target the ones that already have some markings in them. Like here we've got the 3 and the 6 corner marked. So I know this cell's not 3 or 6, which is already helpful to know. It's going to be markable, right? We're down to 5 digits and it's not, at least not 2 of them. But what do we need in this column? We need a 2, 3, 6, 7, 8. So this can be 2. It can't be 3, can't be 6, can't be 7, could be 8. Okay, so it's down to 2, 8. Things I'm looking at here, I'm seeing this 2, 8, and 4, 8. I just need another cell that's 2, 4, or 8 only, and I can form a triple, for example. But I know that these have 3 in them, so we're not going to actually do that in the box. All right. Oh, this row was down to 4. I should look at that. I somehow missed it the whole time. Maybe it's because I placed this 5 more recently. All right, this is 2, 6, 8, 9. Well, this can't be 6 or 8, so this is only 2, 9. Again, looking to see potential triples and stuff. 2, 6, 8, 9. So the 6s might be interesting. No. 2, 6, 8, 9. So this can't be 8 or 9. So this is 2, 6. Does that form a pair or a triple? No. All right, I need water. This has been a half an hour. All right. So that was that row. Let's finish this column up. We needed 2, 3, 6. Wait, what was it? 2, 3, 6, 7, 8. 2, 3, 6, 7, 8. We're looking for anything that can't be 2 of those digits. Unfortunately, these aren't 6 and these aren't 3. That's all we get, right? Yeah, that's all we get. Okay, so I don't think that's helpful. How about this column? It's now down to 4 digits. Oh, we already looked at it though. It was 2, 4, 7, 9, and these are not restricted. This column has 5 left. No, it's 6 left. Let's not do that. Yeah, this has 5 left. There are 4 givens. So what do we need? We need the 1, 2, 5, 6, 7. This is not 5, 6. We know this is 1, 2, 7. This is not 1 or 5. So it's 2, 6, 7. We did not seem to form any new pair or triple or anything. This column needs 1, 2, 6, 8, 9. See how 5 is kind of like a lot harder to think of in your head? 1, 2, 6, 8, 9. These aren't 9, so these are 1, 2, 6, 8. So this can't be 6, so it's 1, 2, 8. This is suspicious to me. It's 1, 2, 7, 8 in 3 cells. Okay, so what I want to think about is what are the digits these aren't. So we're expecting 6 digits because we have 3 givens, right? We have 6 open cells. And so 1, 2, 7, 8 is 4 of them. What are the other 2? They are the 3 and the 4. So we want to think about 3s and 4s over here. This can't be 4. So actually, we've learned this isn't 4 and these aren't 4. So the 4 is in one of these 2. That tells us these aren't 4. In fact, these 4s, so if this isn't 4, yeah, this 4 looking up puts a 4 in one of these 2. It's actually a crossing. It's kind of a simpler crossing because these are all filled. But what does that tell me? These aren't 4 anymore? So we almost, actually, yeah, we need a 4 in this column. Where is it? So this is exactly what I was talking about. We penciled the 4 in these 2. Only reason this isn't penciled with the 4 is there's a 5 sitting there. Now we know the entire box here isn't 4. We know these aren't 4. We know that's not 4, and this 4C's here. And that's huge. That's going to place a 4 here. You can already see in your head that that's going to place the 7 here as well. You want to keep that in your head before you place the 4. You want to remember that you need to place the 7 because that used up our 7. So now we place the 7. And this 4 also gives us the 8 and the 4 up here. So that's not a 4, that's not a 7, and that's not a 7. This is 2, 3, 9, but it's not a 9. As soon as I said it's not a 9, I looked to see where 9 was in the column, and there's 2 places, but it is down to 2, 3. So I need to think about the digits I just got. I got this 7. Unfortunately, I'm not seeing what to do with 7. One thing that might be useful is if there were any digits here or here, but there aren't. To look into this box. We got this 8. Now these 2 8s look in here. That places this 8. That's why I follow up. Puts an 8 in one of these 3. I'm noticing this cell is not marked, and it can't be 4, 8, or 9. I'm not going to look at it yet, though. I think there's going to be easier stuff. This row is down to 2, 6, 9. This can't be 9, so it's down to 2, 6. What else can I do? I got this 8. I got this 8. This box is down to 4 digits. We need a 2, 3, 6, 9. So we know these aren't 3 already. So these are 2, 6, 9. Unfortunately, these can be any of 2, 3, 6, 9. They're not 7. The row needs a 7, but... All right, we are still looking for stuff. Interesting. This box is down to 2, 3, 7, 8. I wish there was something I could do with that. 2, 3, 7, 8. Huh. Did this 4 do anything else? Yes, it matches with this 4. That places the 4 here. Now, unfortunately, we do still have 2 places for 9. But now this box is down to 2, 5, not 5, 2, 7, 2, 6, 7, 9, 2, 6, 7, 9. This is not a 6. So this is 2, 7, 9. This is not a 9. So this is 2, 6, 7. Huh. What can I do with this? So the thing I'm looking at, again, there's 4 digits here. Unique digits, 2, 6, 7, 9. I need 5 in the row, but I already have the 3 marked. So unfortunately can't do anything with that. I've got this 2, 4 pair. I've got this 8, 9. Is there anything to do that's obvious? What did I get? I got this 8. Got this 4. Got this 4. How are 4s doing? Maybe we can do something with 4s. 4s are here, and they're here. Ah, that's all we have, this rectangle of 4s. All right, so 4s and 5s can basically be ignored. This already accounts for all of 1, 2, 6, 7, 8. This can't be 7. Okay, so 7 in this box is here. This 7 looks up, this 7 looks in. So 7's in one of these two, and that is going to point into here. Putting a 7 in one of these two. Unfortunately, we can't really do anything with it. I guess this not being 7 makes it markable. So it's going to be 2, 3, 8. Wonderful. This puzzle ended up being a little difficult. It seemed like it was going to be straightforward, but 2, 3, 6, 9. What? Okay, so what we want to do at this point where we have most of the puzzle marked, first thing is just rescan to see if you like can catch a pair or a triple that you might have missed, because often there will be. Take note of ones that are almost. Try to scan that as well. Yeah, so this column, I'd scanned this column and I saw that 6 was limited to these two. So I don't have a really good reason that I saw that. I was just scanning for pairs and triples, and just kind of when I scanned this column, I saw that 6 wasn't here or here. So that is going to claim this column needs a 6. This is one of these two, so we can't put more 6s in this box. There's going to be one in one of these two, so it can't be over here. So these not being 6 is hopefully helpful. Yeah, so now 7 in this row. Actually, this whole time 7 in this row has been right here. So we can place that 7. That gives us the 2, 9, and 6 now. All right, so that gives us the 8 and the 9. Now I think it's collapsed. We have a lot. Basically, anywhere you look, this is going to go really fast, but don't worry about it. Like everywhere you look, there's just going to be a single to place. We're just plonking the digits. I'm not going to go slow for that. That would be torture. All right. So this would be 2, 9, 7, and 6. This is our 3 and 8 and 2 and 7. This is our 3, 9, and 2. We're just finishing the pairs and triples that we already have marked, right? And we're looking at our corner marks and seeing 8's only there now. We get our 6 here. We get our 6 in this box. Okay, we get the 8. This is 1, 2. This can't be 2, so that's 1 and 2 and 7. All right. I'm trying not to clear things. It takes longer. This is a 6. All right, the 9 is isolated there. What's the other digit here? 1, 1, and 4. All right, let's do the 1, 4. I guess I might have to clean up a little bit. 1, 3, 5. Ah, down here we get the 2. Okay, that gives us 4 and 2. Gives us 1 and 4. Gives us the 1, the 3, and the 5. We can do it that way too. That's 5 and 1. That's 6. That's 3. That's 9, and we're done. 40 minutes. 39. Anyway, lots of explanation, but there was a bit of a tricky ending there. I think these claiming 6s here were not necessarily easy to see. All right, I had some really good stuff in this puzzle. I'm glad I picked it as kind of the tutorial puzzle. It had a lot of almost geometries and then a really nice hidden quad geometry. Proves how nice geometry is. Hopefully this really helped you understand the geometry. If not, watch it again a couple times because I can't think of a better way to explain it. The thing to keep in mind is it's not actually a technique, or it's not actually a technique in the same way a pair would be a technique, right? I'd say it's more of a strategy for finding useful things, which then you apply techniques to. So it's a strategy to make it, to sort of pinpoint the really interesting parts of the puzzle right at the start. And as you go, people get in the habit of scanning the empty cells instead of scanning the information you already have. And you're given a lot of information right at the start of the puzzle, and we want to use that right away. Cool. Well, I hope that this was helpful. It certainly was time consuming. Let me know how you did on this. Let me know if this was helpful for you. And if you enjoyed this, why not leave a like, subscribe, and a kind comment below.